Hello and welcome to the fourth and last video of this tutorial series about how to integrate the SCILL API in your Unreal Engine game. In the last video we had a look at how to implement the Unreal SDK in your game's client. Next we will look at what you need to do on your game server in order to properly use the SCILL API's features. This will mainly cover how to collect the game state and send events to the SCILL API appropriately, and how to receive real-time updates to trigger certain routines in your game to reward the player. First, let us have a look at how to send events to the SCILL API without caring too much about where to best put that in this project. So to test this out, just go to the SCILL game mode that we created in the last video. You can just drag and drop the SCILL client backend component anywhere in the graph and drag off its value to place a send event node. Just like the client-side nodes, this node creates a callback and thus needs to bind a proper event or function that will be called once a response is received. The payload of an event consists of the user ID of the sending user. We can get that from the initiating player ID. The session ID determines whether or not we restart counting. If we set the session ID to a new value, the current count of the event is reset. Event name is used to provide the tracked property of the player. Refer to the SCILL documentation or the event name dropdown in the SCILL playground to get a list of possible names. The event type determines how the event is handled in the SCILL API. You can either set it to single, so that the SCILL backend will add the given amount to the corresponding challenges and leaderboards data. When setting it to group, it will instead set the current count to the given amount. This way you can group several events on your own backend and then send the result as a group event. The metadata struct that is needed for the event consists of a subset of a multitude of properties. Since Unreal Blueprints cannot handle optional values very well, you are presented with all possible metadata at once. Again, refer to the SCILL documentation to find out which events need which of these properties. Also remember to set the corresponding send boolean for any used number value. Strings are sorted out automatically if they are empty, while numbers need to rely on the corresponding flag in the metadata. So this is how to send events to the SCILL API generally. Let us now have a look at how to handle this best in our game. If we recap the second video of this series, we remember that we have challenges for killing a certain number of enemies in a single round, using items or specific actions, reaching a certain wave, and so on. We want to track all these things in a centralized location before sending the corresponding events to the SCILL API. Unreal offers a nice technique to send events to any game object that might track it, event dispatchers. Whenever an interesting event is occurring in your game, the instigator will have to call an event of that centralized tracker. If you need to learn a little about event dispatchers, you can have a look at the Unreal Engine documentation by Epic Games. They have some pretty good how-tos on that topic. But in short, an event dispatcher can be created on any blueprint to create a type of message that can be sent or received anywhere else in your blueprints. You only have to have a reference to the actor that holds the dispatcher to call all assigned events or assign new events to it. The game mode again is the perfect place to track all the changes in the game, since it always lives on the server and thus has all gameplay relevant information at hand at any time. It is only accessible from the game server, but there you can access it from anywhere, and also there's only one game mode. So to make it easier to track the different kinds of events, we will create the dispatchers on the game mode and then make them accessible to all relevant senders of these events. You can also create an own actor component that handles all of this logic to make the code more reusable. But for this tutorial we will just stick with putting it in the game mode directly. In our SCILL Blueprints folder you might also want to create a blueprint library for all SCILL-specific global blueprint functions. We could create a getter for the SCILL game mode that casts the current game mode accordingly before returning it. This will make working with it a little bit easier. In the SCILL game mode again, for each event we will now create an event dispatcher. Let's do all this for the kill enemy event as an example so you can copy it to any other event you want to implement in your game. Go to the event dispatchers of your game mode and add a new one called kill enemy. Add an integer input to its signature in the details panel called amount. Now drag it into the blueprint right behind the parent begin play node and hit bind from the drop-down menu. Now drag off the event pin and select create event. Here you can choose to create a matching function. In this function we will handle the kill enemy event. For this you will need to create an instance variable that keeps track of how many enemies we have killed in the current game. Go to the game mode's instance variables and add an integer called enemies killed count. In the receive kill event function, add the incoming amount to the enemies killed count and save it back to that instance variable. Now, in order to call that event, we need to find the correct place in the existing blueprints of the sample project. The enemy character blueprint has an on-death event that occurs if the player defeats an enemy. Here we need to make sure to send an event with the amount of killed enemies to the game mode. Just retrieve the game mode with the blueprint function from the library we have created earlier and call the kill event dispatcher's event from here. Now we track the amount of enemies in our game mode, but we still do not send anything of that to the SCILL API. In the game mode we need to add the sending process at an appropriate point in time. A good idea is to do that once the game is over. This can happen in 3 ways in this game. The player can time out because he killed too few enemies, he can lose all his health points, or he can defeat all 20 waves. All these are handled in the onGameOver event on the sample project's game mode blueprint. So let us override that event in our SCILL game mode blueprint. Right click anywhere in the event graph, find the event onGameOver entry and click it to add it to the graph. Now right click the node and select add call to parent function and lastly connect the 2 nodes. Create a function that capsules the logic that is needed to send all the events to the SCILL API that need to be sent at the end of a game. For now this is the kill enemy event. Place a send event node from the SCILL client backend component and drag off the response received pin to create a matching function. We do not need to do anything really with the response, so we just leave it as it is. Then create an event payload structure. We care about the user ID and session ID later on in this video. For now let us put the event name kill enemy and event type single in here and add the metadata. Drag off the metadata pin, check the send amount flag and bind the amount property to our enemies killed count instance variable. There are some additional optional values we could send, but we do not need them for our challenges, so we can just leave this as it is. So now we need to make up a user ID. Of course, you would rather use the user ID that you have associated with a player in your game's backend. For this tutorial, we want to use a unique ID that we can create without having to program a custom backend first, and that is still unique to the machine that this game is played on. We can use the internal getDeviceID function of Unreal. This unique device ID stays consistent over several play sessions and so is a perfect fit for our case. Next we need to take care of the session ID. Each playthrough has to have a unique ID, so we can surely use a GeoID, a globally unique ID, and just store it in the game mode. We want to generate a new GeoID each time the game starts. The game mode has an event for that again that we can override, the start game event. Add it to the SCILL game mode and call the parent event and then generate a new GeoID, cast it to a string and promote it to an instance variable called sessionID. We can now use this on our sendEvents function at the end of the game. So this is all we need to do to send events at appropriate moments to the SCILL API. The workflow with placing everything related to that in the game mode is just a recommended practice, but there might be other ways that fit better into your specific game. So you really do not have to follow these steps 100% accurately. Also, if there are events that you want to send at different points in time, for example immediately after the player triggers it, you can simply adjust to that in your custom event dispatcher's handlers. This should be enough for now on SCILL events. We still have one last topic to take a look at. Handling changes on the challenges, for example to reward players. The receive real-time update functions live on the SCILL client components, the component we have placed on the player controller. So instead of handling this on the game mode, we will make sure to handle it on the server side of each player controller. Of course we can also add a SCILL client component to the game mode just to handle the updates, but it will need to have the user's access token nevertheless, and as long as we are on the game server we can safely manipulate the game state. Since we looked at the kill enemy event in this video, let us have a look at the personal challenge that is using that event name to track the player's progress. Kill a certain amount of enemies in one play session. Once completed, we will reward the player with 150 souls that he can spend on unlocking weapons or skills permanently for all following runs. You can use the same procedure that we discussed for personal challenges for battle passes and leaderboards. In the begin play event of the SCILL player controller, we need to add a check whether we are on the game server or the client. If we are on the game server, we can start receiving the challenge updates. Again, you need to drag off the response received pin to create a matching function that is called each time a challenge of the current player has changed. We will implement that function soon. But first we need to handle something that we did not handle earlier. When you try to run this, you might notice that you cannot subscribe to the challenge updates. This is because your player controller on the server currently does not save the access token we generated in the last video. Go to the function that we have created back then, that handles the response on the server side and calls the client's set access token event. Here we want to set the access token property of the SCILL client as well. Now head back to the function that handles our challenge update. We want to reward the player the current amount of souls once he completes a challenge. So we just need to check if we receive a challenge update of a now finished challenge that was previously either unclaimed or in progress. This change indicates that the challenge had just been completed successfully and the reward was claimed afterwards. We can do this by checking against the type property of the new and old challenges. If that is the case, we can now reward the player with his earned souls. In the challenges we have created for this project, we have used the challenge reward type coin to indicate that we want to reward souls, and the challenge reward to indicate how many souls. So check if the reward type is coin and then cast the reward to an integer and add it to your player controller's souls count. For other reward types you can make other code paths with different handlings, like adding items to the player's inventory with a specific ID. Adding souls in the sample project is not properly handled for a server client setup, so we would have to make slight adjustments to the code to make this work in our scenario. For example, replicate the add souls function to the client as well. But this is specific to your game and how you handle your player's inventory and other stats. Sometimes it might be enough to just start replicating an instance variable of a blueprint. So now when we start the game, we can see that not only we can keep track of our challenges, battle passes and leaderboard, but we can also kill enemies to create high scores in the leaderboard and complete the corresponding challenges. Now all you have to do is to repeat the tracking and sending of gameplay events in a similar way to support all challenges, battle passes and leaderboards of your game properly. Also you can download the finished sample project where we have a lot of cases that are slightly different from the discussed ones but might still be worth looking at. So I hope you now have a good idea of how to integrate SCILL in your Unreal Engine game to create player motivation and retention using these concepts and integrating them in your game efficiently. Have a nice rest of your day and take care. Bye.